Project 2.2, ISP.Long, the 4-player reaction time game. This project combines hardware, coding, and design into a fun and interactive game. The following sections will break down the functionality of the game and how it works. Here is the game and how it works. Once the start button is pressed, the game begins with a countdown sequence signaled by 3 LEDs, a red LED, a yellow, and a green. The LCD also reads, "Wait for it." Players must carefully watch the LEDs and wait for all the lights to go out before pressing their button. Each player has their own button, distinctively colored to match their assigned LED, red, yellow, green, or blue. Once the light goes out, the players must press their respective buttons as quickly as possible. The system records the time elapsed between the lights going out and the button pressed. The game registers the first button pressed and shows their reaction time on the LCD and awards them a point. The results are continuously displayed on the screen. The game can be reset for another round, and that will be shown on the LCD. The entire game is designed to offer immediate feedback and a fun experience. The Breadboard Prototype serves as a testbed for the components and overall functionality. It uses a 20x4 I2C LCD to show instructions, reaction times, and scores. Thanks to the I2C interface, it only needs 2 connections, SDA and SCL. 4-player buttons are wired to pin 8, 9, 13, and A0 with pull-down resistors for stability, and 2 extra buttons reset on pin 6 and the on or power button on pin 7 using the same setup. 4-player LEDs, yellow, blue, green, and red, connect to pins 5, 4, 3, and 2, while 3 countdown LEDs, red, yellow, green, are wired to pins 12, 11, and 10. Each LED uses a resistor to limit current and is grounded. Together, these components create a functional prototype that brings the concept of this game to life. The PCB is created using EasyEDA. This starts with a schematic, which was designed to integrate all components cleanly, ensuring compactness and reliability. Routing paths were optimized for efficient use of space, with traces carefully planned. A small PCB reduced the overall cost by minimizing material use, cut down on wait time during manufacturing, and improved aesthetics by keeping wiring hidden so the PCB didn't sit at the top. The final PCB is compact and sits flat inside the case, providing a strong platform for wiring and ensuring all the components remain securely in place. Design was a key part of this project. The case was designed with both functionality and aesthetics in mind. Fusion 360 was used to create a precise and functional 2-part case. The main body houses the PCB and internal wiring, keeping everything secure and organized. The lid fits neatly over the case, featuring precise cutouts for the LCD, buttons, and LEDs, ensuring they are accessible while protecting the internal components. This was difficult as the cutouts needed to be perfect for all the components to fit. The large dimensions were chosen to provide a sturdy and game-set feel, while maintaining portability and ease of use, adding both practicality and a professional aspect to this project. The code is structured with key variables and functions to manage the reaction time game efficiently. The Liquid Crystal I2C library is included to handle the I2C connected LCD. This library simplifies the process of setting instructions to the 20x4 LCD. The button lock module variable prevents multiple button presses during a single round. The on button state and reset pin state variables monitor the start and reset button states. The reaction time and start time variables calculate how fast a player reacts in milliseconds. All the button point variables track each player's score and updates dynamically. The reset block function clears the game state, resets scores, turns off LEDs, and updates the LCD to a reset or ready message. The random delay function adds a 1 to 5 second random delay before the timer starts and the LEDs count down and then go out. Start time module function is the game's core. It tracks and displays reaction time on the LCD. It detects which player's button is pressed, lights up their LED, and increments their score and locks other buttons. And it monitors the reset button to restart the game when needed. In the loop function, it continuously checks for power and reset button presses, and unlocks and starts the game with random delay if the start button is pressed, and it updates the LCD in real time. A main part of this code is the button lock mechanism, which ensures smooth gameplay by deactivating all buttons immediately after one is pressed, preventing scoring errors and keeping rounds fair. Overall, the 4-player reaction time game combines principles of electronics, coding, and design to deliver an engaging and fun experience. By starting with a breadboard prototype, transitioning to a custom PCB, and then finalizing it with a 3D printed case, the project showcases the journey from concept to completion. This is Project 2.2, ISP.Long, the 4-player reaction time game. Thank you for watching.